you know, I heard about PiDay, so I just wanted to make a little magic for you. Hi.
Okay. And you're also wearing Buckets' birthday shirt.
Of course. I mean, what other option is there? Let's be real.
Hi, Emily. Welcome to the show.
Hi,
How are you doing?
Darko. Hi, Jasmine.
Hi.
I'm doing well. Hey, Chad. Good to see you out there.
So, Emily, tell us who you are. Who are you? What do you do? And what's the best language model, large language model?
Yes. Okay. So hey, Chad. We're going with the easy questions. Hi, my name's Emily Weber. I'm the tech lead for Gen AI on SageMaker. Been with AWS for 6 years. And the best large language model is the one you are about to build. That is unambiguously the most exciting language model out there, is the one that you are about to create using your own data sets, using your own data lakes in particular.
Okay, good, amazing.
That's exciting.
Emily, so you're here to talk to us today about a bunch of things, right? We're going to be talking about training a large language model, which may be very, very complicated, or not. We're going to be talking about how to bringing natural language into a data lake.
Yes.
And all of those kinds of things. So talk to us. How do you connect a data lake to a large language model? What's the deal there?
Yes, definitely. So honestly, I feel like this is probably the most exciting question to be asking right now.
Okay.
Is because your data lake, in many cases, is this very large, construct of relational data sets. In many cases, so you have tables in Athena, you have tables in Redshift. You're interacting with CloudWatch logs. You're interacting with all of these disparate data sources, and then your data lake is essentially the place where you bring all of these pieces together. A really nice example of this is the security data lake, actually.
Okay.
So a security data lake service in AWS that you can use to combine all of the disparate security data sets and then understand these. What we're going to take a look at is interacting with your security data lake through Claude, actually. So we're going to use Claude 3 to perform what's called text to query.
Okay.
So we're going to generate some SQL queries, and then I'm going to show you the results of running those SQL queries using the data lake.
Okay, that sounds pretty exciting. So, Emily, can you make your screen full screen right now?
I can indeed.
Command plus it a couple of times so you can see this nice and easy.
Let's do it.
And we're going to be showing Emily's screen right now with a demo that includes data lakes and some machine learning.
Yeah, so first off, the data set we're going to use here is called a VPC float log.
Okay.
And essentially this is network traffic where all of your hosts on AWS, essentially you want to know what other IPs those hosts are hitting. And this is a way to understand bottlenecks in your networking and also a way to perform incident response in the event of a security attack. And so what we've done is we wrote an essay about VPC flow logs, and we wrote an essay about the security data lake.
So is that an essay? Is that?
This is the response, actually.
Okay.
So let me see if I can scroll up. So the essay is comprehensive, and it provides a primer to the open cybersecurity schema format and explains to a non-security expert what this data set is, what it is used for in, again, performing incident response, and then many examples of working with the Amazon Security Lake, including, again, the data set formats, the data types, and then, again, examples of this. And so we can ask Claude basic questions. We can say, what is the security data lake?
So typically, who in an environment would write this type of essay?
Yeah, so this essay came from our security specialists.
Okay.
I think it's interesting to look at in, sort of modern data lake architectures where that content and where that essay comes from. You can use that from sort of open source data sets or like narrative documents that have already been written about that, type. And then, honestly, we can also use Claude to write those essays, really, because Claude definitely had some context about a security data lake, but it didn't have sort of that expert, on-the-ground knowledge. And so that was what we brought using this essay. And so it's definitely, in response, able to tell us about the security data lake, which was pretty exciting.
So my understanding here is that so you first explained to the model what is what's a VPC flow log. This whole essay explains a bunch of things that's required from it. And did you just point it to some data, or how did it?
Yeah. So first we just ask it, what is the security data lake?
Okay.
And then we'll ask it another question, which is write a SQL query for a security data lake that summarizes blocked traffic in the last week.
Okay.
And we're going to run this.
One thing, chat. So this is a foundational model. It hasn't been trained additionally, hasn't been fine-tuned or anything like that. It's not even using a knowledge base here specifically. This is all being run from these prompts that Emily has provided. That big essay is a big old context of what this is and what it should do for. What should it do with it? Okay. So what do we have here right now?
So what do we have here? Yes. So what we have here is an example of a SQL query that summarizes the block traffic in VPC flow logs in the AWS Security Data Lake. So what we're going to do is we're going to copy this.
Okay.
Just going to copy this, and then I'm going to open up Athena.
We always come back to Athena. This is the third time we're mentioning Athena today. Hi,
Goddess
Athena.
of wisdom.
Yeah, Athena is the service of the day, apparently.
Yeah.
Okay. By the way, folks out there, Athena is a service that enables you to query data stored on an S3 bucket. It's just simple as that. So it's a glorious little service that just allows you to run SQL queries on a bunch of data.
Great. All right. And so here is the query. And so it's selecting the source endpoint, et cetera, et cetera. And then this is the result of the query, actually.
Okay.
So I did run these queries ahead of time.
Okay.
So we'll look at the result. But so in any case, we get a source IP, we have a destination IP, we can see packets, we can see bytes. And then what we're going to do is we're going to pick this first source IP, and then I'm going to go back to Bedrock, and I'm going to ask Claude, we're going to say now write a SQL security lake command that summarizes traffic to and from this host. And that is this. And so first we use the language model to generate the query. Then we go execute the query ourselves in the Athena data lake. Then we're going to come back and find something in that trail that we want to do a deeper dive on. In this case, that was a host. That was an instance ID. And so we're going to bring that back. And then I asked Claude to generate the SQL query using that specific source endpoint or destination endpoint. And then we're going to copy this. And we're going to go back to Athena. And then that is what I pasted in ahead of time right here. So it's that same source endpoint or destination IP. And then it shows it here. And we get all the packets and all the bytes and all the traffic. And so this is a way that you can chat with your data lake. Really, is taking all of the data sets that you're interacting with, generating queries from those using natural language. And so this is great, especially for introductory developers or for onboarding new team members who aren't already experts in that data lake, who aren't already experts in that relational structure that you've created. You can easily help them become proficient using large language models.
Yeah. Does this work for all kinds of data?
Yeah, so when we're onboarding new data sets, it's really interesting because you actually want to go create more constructs and more of that broader context. So that same essay that we provide, like you can use part of that essay for sure. So you'll be able to explain, here is the broader construct, here is the domain, here's the reason why we care about this data. But then let me give you a couple examples of using that specific data type. And so that way you can use this like base prompt, really, which is what it is. You can reuse like 80% of that prompt, I would say, and then just add a couple different examples of few-shot prompting that focus on that specific data set.
This makes me very happy. So as a person who used to parse logs in the past, I used to, maintain big systems, and you got a lot of logs, and something goes wrong, or there's some sort of an anomaly there, and I've been given this huge log file or JSON object, and okay, and then you see me spend 12 hours writing that SQL query. But this, like, again, the thing is here, the model here does not actually have anything to do with your data. It's not exposed to that specific log, right? It doesn't have access to it directly. It just helps you work with it, right? You are, in essence, transforming natural language, your questions, into SQL queries.
Yeah, I mean, it's incredible. Like, I remember, taking classes in databases where, your homework assignment was going home and writing a SQL query.
Yeah.
That was your work. And I mean, it's still useful and interesting, but it's wild to see, how quickly that task can be accelerated using LLMs.
Yeah.
Nice. Okay, so we do have a couple of comments here. By the way, Emily, we have a fan in the chat. VJ1900. Hello, VJ. Thank you so much for joining us again.
Hi, VJ.
VJ is asking, does Haiku know which is the latest mountain Emily scaled? Emily, for the folks out there, Emily loves climbing mountains. The taller, the more complicated mountain, so I don't think Haiku knows that yet. We may need to teach it.
Yeah, I think Twitch knows that, but much of the written world doesn't know about that. There's not a blog post about it, nor an essay, so I don't think that Claude would know that.
I love it. So there's another comment here from ALX_Nan. How do I connect Bedrock agent to my API if I have better authorization? Do stand by. We're going to have Suman come back, and we're going to talk about a lot more about Bedrock. So we're potentially going to ask Suman that same question. So ALX_Nan, do not go anywhere. Emily,
Darko.
what is a better way? Is there a better way? Like, we saw a data lake here. Is there a better way to integrate data lakes into generative AI?
Oh my gosh, yes.
Yes.
It's so exciting. So not only can you use your language model to talk to a data lake, but you can actually integrate the two. You can make them one.
One with everything?
Yes. Yes. So the way you're going to do that is by fine-tuning and or pre-training your language model with your own data lake.
Oh, nice.
Right?
So that sounds complicated, and maybe it might take a lot, but how much data do you need to train an LLM?
Yes, definitely. Very important question. So if you are fine-tuning a language model, really you don't need very much, actually. If you're fine-tuning a language model, you want to focus on having high-quality data samples and a smaller number of those. So maybe 1,000 really, really good samples is sufficient for small-scale fine-tuning. As you look at adapting that language model and as you look at increasing it, you want to consider the complexity of your task. And you want to consider how different that target domain is from the upscale domain that data set and that model came from. So if they're vastly different, then you want a lot of data.
Okay.
If they're pretty similar, you don't need that much.
But okay, so what? Okay, we're talking about the cloud scale here. So when you say not a lot of data, what does that actually mean?
What does it mean?
What is it? What's not a lot of data? Is that like 7 megabytes of data? Is that a floppy disk's worth of data, or is it?
It's probably more than a few floppy disks. I would wager. But yeah, if you're doing a small scale fine tuning, then I mean really like 1,000 samples where you have an instruction and then you provide the result of the language model following your instruction. That is solidly under 1 GB. That is not a large data set for fine-tuning. I've seen some fine-tuning data sets that get a little bit closer to the 5, 10 GB range, but it's pretty rare to see a fine-tuning data set be much larger than that. Once you look at pre-training your own language model, then you're moving closer to the hundreds of GBs, 1 terabyte, multiple terabytes. And that's the scope that we see foundation model developers building on AWS and on SageMaker today, which is where, again, they have multiple terabytes of very, very high quality language data. So again, it's in this narrative format, this essay format that reads like a book, reads like an article, like a novel, and then you throw that into your large language model on SageMaker using SageMaker training and all sorts of other goodies to train your model.
I like that. I like that. So, are we going to see a demo today about something? I know we talked about we're going to see some SageMaker today that's gonna show us some sort of model training. But while you're doing that, chat. Hello. How are you all doing? Yes, I see a comment here about 45, 3.5-inch floppy disks to install Microsoft Office. Chat, tell us how much megabytes do 45 3.5-inch floppy disks have? Voice your opinions in the chat. Emily, what are we going to see here in regards to the actual training?
Yeah.
What's the demo?
Let's check it out. So first off, you can do the same thing with me.
Okay.
So the demo here is available on GitHub. We'll drop it in the chat maybe in a little bit here.
Yep.
But in any case, this is on GitHub in the SageMaker Trainium examples. And so in this case, essentially, we're going to use one notebook to train Llama 2 70B on SageMaker using Trainium instances.
Okay.
And so this is all contained really nicely in the one single notebook. This does the pre-processing and it does the tokenizing on the notebook itself, actually. So I used Amazon SageMaker Studio. I used actually the classic version of Studio. And using this, so I start with a smaller machine, right? This is a T3 medium, very gentle, small machine. And then when I move up to the larger processing, because I'm downloading this tokenizer, I'm downloading the data sets, and then I'm actually tokenizing a large volume of data, actually, I'm going to switch out to this C5 machine. So many more CPUs, lots more storage, lots more memory, and then again, more processing power, so I can do that processing very, very quickly. I love how Studio makes this so simple, right? Because I'm in one IDE. I'm not leaving my notebook, but without leaving my notebook, I can actually switch my backend to run on different types of compute. So it's really awesome.
So you're able to scale up and scale down very quickly.
Absolutely.
How do you make sure that if you're scaling up or scaling down that you're utilizing those GPUs?
Yeah, sure. So for notebooks, I'm not as concerned with utilization, to be honest. And that's mostly because, I mean, first off, these are CPU-based machines, so they're a lot less expensive. And second, notebooks are sort of, they're a more casual game, right? Like, you're going to leave a notebook up for maybe an hour, you're going to turn it off. A lot of customers run lifecycle configs in their Studio domain to just turn off the instances when they're not being utilized. So that's fairly common. What I care a lot about is the GPU and the accelerator utilization, because these are Trainium instances, actually. I care a lot about the GPU and the accelerator utilization right here. And so I'm scrolling through this very quickly, but in any case, what this is doing is this is creating a new training job that is letting me pre-train my own 70 billion parameter Llama 2 model. And I'm doing this right here in the notebook. So this object you see, this is a wrapper around the API to create a training job. So you're going to create a new training job on SageMaker using this. And then I'm bringing this script to actually execute that training loop. So it's doing the forward and the backward pass right there. I'm passing in all of my Trainium instances right here, my overall world size, my S3 location where my data sets are stored, the distribution type, and then when I call estimator.fits, we're creating this training cluster on the fly. So I'm creating this ephemeral training cluster of 8 Trainium instances. And so all of these are orchestrated and managed by SageMaker on my behalf. Then I can view and manage them all in CloudWatch.
But okay, so let's explain something to chat. What is a Trainium instance?
What is a Trainium instance?
Sounds amazing. What is a Trainium instance?
It is amazing.
Okay.
Yeah, so Trainium, of course, is hardware that's coming out of Amazon. So this is custom chips, custom silicon optimized for machine learning model training and then for machine learning model hosting. And so Trainium is a way to get really, really good price performance, essentially. So you're going to see excellent performance and price performance on these machines.
Dedicated silicon for specifically for inference and training, right?
Exactly.
Beautiful, beautiful.
Exactly.
Awesome. So you're creating this training job that's going to run on a bunch of Trainium instances. I see something here called, and this is something we haven't touched upon yet because it's all about storage today, Emily. I see like input mode fast file. So you're pulling the training data, I would imagine, from S3, right?
That is correct.
Okay, awesome. Are you just downloading the whole training data, or what's the deal?
No, yeah. So fast file mode is a SageMaker data type. Basically, it's a way that you can, from your SageMaker training job, that you can essentially, it's like a streamer, basically. But it's a way to essentially read objects from your S3 bucket in a manner that lets you read them very, very quickly. Without needing to wait for the entire volume of data to be copied over. And so fast file mode is great for sort of that like Goldilocks zone of data that's just large enough to let you do something meaningful without being too large that you need something that's much more suitable for something that's distributed at a large scale. The alternative, of course, is FSX for Lustre.
Okay.
And so FSX for Lustre is a great fit for, again, very, very large data sets. So if you're actually pre-training your own language model, you have multiple terabytes of language data and maybe image data as well if you're doing a stable diffusion type training or even a mixture of experts with Mixtral, then in all of those cases, basically, FSX for Lustre is going to create this distributed file system for you. So you start with your data in S3, and then in the console, you're going to create an FSX for Lustre file system that actually first it copies the metadata onto the file system. It'll do that in like 10, 20 minutes very quickly. And then as you set up your distributed training job, and as you have hundreds and then thousands of accelerators, and all of those accelerators are trying to read your data from that through your data loader, basically Lustre is going to add more bandwidth, like linearly with all of the reads, basically. So as you have more and more hosts that are asking for data, Lustre creates more ability to read that. So it's super nice.
Yeah.
And then you use basically this like lazy loading capability, which is where first you do a full pass on your data to copy the data from S3 into Lustre directly, not just the metadata. But then once you've done that first pass, the reads are just very, very fast. And so this is both for SageMaker training and then for SageMaker HyperPod, which is our managed cluster environment, if you want to interact with it through Slurm.
So a couple things. FSX for Lustre, to explain to the folks out there, imagine it as a big old shared network storage that's super fast, and then it automatically ingests data from something like Amazon S3. It is critical for such workloads because you want to, how do you call that?
Hydrate.
Hydrate. So, chat, we have to talk about what hydrating means. It's hydrate. You have to hydrate your GPUs. The thing is, your GPUs should not be idle. The thing is, pass as much training as data as you can into it, keep them hydrated, and have them working for you, training your model. Idle GPUs are bad GPUs, or well, not bad GPUs. They're expensive GPUs. So
They are.
fast storage is important. HyperPod. You mentioned HyperPod. That's
I
kind of
did.
what is HyperPod?
Well, what is HyperPod? So SageMaker training, of course, gives you a lot of capabilities. You have node hot swapping, you have automatic GPU health checking, you have these distributed training libraries, you have a lot of optimization. Not everyone wants to work with this training job API construct necessarily. A lot of customers really want to just work with the boxes and just roll with it.
Yeah.
So HyperPod is really like devoid of abstractions, if that makes sense. It's like slightly, it's a different way of interacting with the compute, really, because in SageMaker training, you get this ephemeral training job experience where the instances are going to come online for a short period of time. You're only paying for that period of time, so it's very flexible and very friendly on the pricing structure. But again, some people just want to turn on the machines and just have them stay there stably until they turn them off, and then interact with that and run jobs with that using Slurm. So Slurm is Slurm, yes.
Sounds hydrating, but okay.
Yeah.
Slurm.
yeah. so Slurm is basically a job management framework for high performance computing,
Okay.
where you can use Slurm to execute and send jobs to a cluster. And so Slurm is one way to do that on, say, SageMaker Hyperpod, where you can send jobs. So like your whole team, for example, of research scientists, can submit jobs to this training cluster using Slurm.
Okay, that's pretty cool. That's nice. I see somebody in chat saying, hearing Slurm, they think of Futurama. Exactly. That was my thing of Futurama as well. Okay.
That's actually where it came from.
Oh, really?
They literally based it on Futurama, the name.
That's nice. Someone else in the chat said, don't let GPUs get thirsty.
Never. Your GPU should never
You
be
might have
thirsty.
to put that on a sticker.
I love it.
Amazing. So let's go back to your demo. I want to see this a bit more here. So if we go back to Emily's screen right now, we see this pi estimator object here, right?
We do.
We don't yet, but we're trying to get there. What are we going to be seeing there? There you go. We see it now. So we see you. This is basically configuring a training job. Where does this training job run right now?
Where does this training job run? It runs on AWS, my friend.
Okay, does it? Interesting. What is this thing AWS called?
So how does that work? Yeah, so this is my little baby notebook instance, right? This is my T3 Medium sitting here in SageMaker Studio.
Okay.
I'm bringing my scripts. You can see them in this local path that I have right here. So the scripts folder, that has all of the content that I want to run here. I've got all my hyperparameters set, and then I'm going to call estimator.fit. Then again, when I do that, this is actually turning on those instances. It's turning on those backend machines. And then I can see the logs here if I want to like view and troubleshoot it, or I can look at all of the metadata out here in the SageMaker control plane. So something that's so nice, honestly, one of my favorite aspects of SageMaker training is that it just holds on to the metadata for you.
Yeah.
It's a beautiful thing. Like years ago, if you want to go dig up an experiment that you ran on the fly because you thought it sounded cool, you can go search through your SageMaker training metadata, basically, and go dig up that job, and you can backtrack and see, oh, this was the training image that I used. This is how long this job ran. This is the number of instances that I ran with this job to train this model. Here's my training data set in S3. Here's my output path, also in S3. Here are all of the hyperparameters that I used for this job. And then we can actually go down and we can check out the logs for this thing. And so the logs will take us back to the top, and then I'll see if I can go dig up the later version. But in any case, it's really useful because we can see all of these components, so we can keep them, together. Then I can compare them.
Yeah.
I can build pipelines on top of that, so I can build this into like my integration stack or my deployment stack. I can retrain this periodically. So it's really awesome.
Amazing. So now these are all kind of fully managed training jobs, right? So you don't have to, that's what we want, right?
Yeah.
So that is definitely what we want. Yeah.
So how long does it take to train Llama 2?
Months.
Yeah.
Months.
Like months as in like 2 months plural, or like 24 months?
2 months.
Okay.
2 months.
Depending on
Yeah.
the GP, it depends.
Yeah.
It depends, right?
It definitely depends. So most teams will do for Llama 2. I mean, you're looking at anywhere from hundreds to thousands of accelerators generally, somewhere in that range. And then within that, obviously, when you put more accelerators on the problem, the job will run faster. Okay. Not necessarily, though. It's kind of interesting just to look at how the network actually gets really bottlenecked by all of the accelerators that are passing the gradients to each other across the different hosts in the overall cluster. And so we have, again, distributed training libraries and lower level optimizations to speed that up that are optimized for the AWS network topology, which is really cool. But so in any case, so your Llama 2 is probably going to take anywhere from, I'd say definitely quite a few weeks if you're doing a very, very, very large cluster, or you could do something that's more, say, a medium to large style cluster, and then at least a solid month, maybe push in 2 months.
Amazing, amazing. Now, that's very important to know because, like, fine-tuning models. So is this not this is training models, completely training from scratch, right?
Yeah, it
training
is.
models is something that you don't tend to do very often. Like you shouldn't. I mean, unless that's your business. But like most customers, most folks you out there will not train your model necessarily. But if you're doing that, remember a couple of things. Number one, takes a lot of time. Number two, keep them GPUs hydrated. Number three, use something like SageMaker to help you manage your training jobs, your metadata, and everything in between.
And
Hyperpods.
the last point is consider integrating this with your data lake.
Yes.
Like,
yes.
seriously, let's send our data to LLMs. Right?
Yeah.
Absolutely.
It's just such an exciting pattern to look at.
Let's send our data to LLMs. I love it.
Oh, and then one call out is if you'd like to learn more about pre-training large vision and language models, feel free to check out my book on the topic. I did write a book about this. It came out last year. It's full of lots of examples. So the book covers pre-training foundation models in vision, as well as language, as well as intermediary. I give you lots of state-of-the-art examples of really interesting models, really interesting training frameworks that you can stand up, distributed training fundamentals, and then essentially managing the entire life cycle of foundation model development, training, hosting, and operationalizing on SageMaker and on AWS. So go read.
Definitely go check out Emily's book. Before we leave you, we're going to have to say goodbye to Emily in a second here. But I also want to kind of do a little tangent to what you're talking about, right? We talked about training jobs and feeding, hydrating your GPUs. I want to show some feature that came over from our friends over at PyTorch. I want to show my screen right now, right? I want to show you a feature that's called S3. Amazon S3 connector for PyTorch. What is PyTorch?
What is PyTorch? PyTorch is a framework for deep learning. So yeah, it's a way you can both use a neural network that someone else built, and you can build your own neural network from scratch.
What is amazing about this plugin, this feature right now, it enables PyTorch to basically, in a more optimized way, get data for training from Amazon S3, right? Instead of me having to download data locally or me having to stream data to here, all of these things, including creating, writing, and reading checkpoints to S3, is handled by this connector. So this is a little notebook that does that. Basically, what I'm doing here is pointing them to a bucket that contains a bunch of images, and what it does, it actually loads all of those images into a specific data set. By doing that, I can just access different objects in this array of images, and it loads them in a very optimal way. So like in this case, there you go. It loaded an image directly from Amazon S3 that it's going to use potentially in some data stuff. Unfortunately, I don't have time to kind of go through this whole thing, but if you are a user of PyTorch and your data is on S3, because of course it is, do check out the Amazon S3 connector for PyTorch, because it's going to be your big friend going on forward. Amazing. So, Emily, thank you so much.
Thank you.
It's been a pleasure. It's been a pleasure. Go check out Emily's stuff, book, blog posts, all the amazing videos of machine learning she's done.